Welcome back, guys. In this video, we got to simplify this expression here. So we got the square root of 144x squared y cubed times the square root of 16y cubed times x. So working with some radicals here. So basically, when you're square rooting a bunch of stuff, so let's say you're square rooting AB, that's equal to the square root of A times the square root of B, right? We know that rule. So what we can do is we could split up the square root into the square root of 144 times the square root of x squared times the square root of y cubed, and then times here the square root of 16 times the square root of y cubed times square root of x. Right, and let's just go through them one by one, see what we get. Square root of 144, we know it's 12. The square root of x squared is just x. The square root of y cubed, let's actually come back to that. Let's leave it for now. Square root of 16, that's 4. Square root of y cubed, let's leave that again. And then the square root of x, can't simplify that any further. Now, notice how we have the square root of y cubed times the square root of y cubed, so we know that's just going to be y cubed there. But let's say that wasn't there. I went over this in an example in the lecture videos. Basically, if you have something to the power of an odd number, you want to split that up into the highest even number you can. So the highest even number closest to 3 is 2. Times the square root of y, right? Because y squared times y to the power 1 is y to the power 3. You're just adding the exponents. Then the square root of y squared is just y. And then that ends up being the square root of y. So this simplifies to that. Now, what if this was a higher degree? So let's say this was like y to the 7. Well, we would split it up into y to the square root of y to the 6. Right? The highest closest even number times the square root of y. And then the square root of y to the 6, if you remember, I mentioned that when you're taking the square root of a variable to an even exponent, you just take that even exponent divided by 2. So this would end up being y to the 3 square root y, like that. Right? So basically, 12 times 4, that's 48. This x can't do anything about. This square root of x, let's put it here. And then the square root of y cubed, that simplifies to that. So we'll have y times the square root of y. And then this here simplifies to that again. So y times the square root of y. And then we can simplify this even further, because y times y is y squared, and then square root of y times square root of y is just y. And so y times y squared just gives us y cubed, which makes sense. Square root of y cubed times square root of y cubed is just y cubed. But I wanted to mention this because it's not always going to happen that these exponents are going to be the same. Like let's say this was y to the 7. Right? Then it would be a little different. This would simplify to that. But then this would simplify to that. So this would be y cubed square root of y. So then y cubed times y would be y to the 4. Square root of y times square root of y is just y. So y to the 4 times y would just give us y to the 5 here. Okay? Wasn't like that, but thought I would mention it. All right, so a little bit tricky, but basically 2 rules you want to remember. Anything that gets square rooted, multiple things get square rooted. You could just split up the square root, sort of distribute the square root to everything. And then the way you simplify variables to the power of an odd number is like this. Pick the highest even number, pick the highest even number. And then the square root of a variable to the exponent of an even number is just that exponent divided by 2.